Hi everyone, my name is Manvi Kumbo. So today I will be presenting my work on assignment 3, which basically focuses on image convolution and neural network training. So basically this assignment is divided into two parts. So part 1 includes explores image convolution, a fundamental operation in computer vision for detecting the patterns, and part B involves training a convolutional CNN on dataset to classify the images. So let's dive into the details. So basically we have part A, which is convolution. So so this is the code which is provided by the assignment. So everything is working properly. And then we have part B for the section which we are supposed to do. So if we go here in the part A, yes, in the part A, we are supposed to do this first question, which says that based on the kernels represented on the above images, create a kernel to detect the 45 degrees using a convolution to apply the car's image and plot the result. So basically, we have to use this and then we have to make sure that the degree is 45. So I wrote this code. So with the 45-degree line detection, the image is coming this way. However, the first image was shown as this way. Then we have a second question which says the apply the following kernels to the image and plot the output. So this is the basically the NP array which we have to use. And if we run this code, then we can see that the edge detection for the kernel one is represented like this. And for the second one, which has a different numbers here, if you see for the NP array, it shows us the kernel 2 image here. And then for the kernel 3, we can see the image which has the different numbers again, which is slotted here. Then we have the part B. Then in the part B, we are again importing the libraries and preparing the dataset. And then we are loading the dataset, and then the hot code one hot encode target values and converting those integers to floats and then normalizing it from the range 0 to 1. Then we are creating a model, and we are doing a model completion by displaying the summary of the details. So you can see the summary shows us the layer, output shape, and the params for the same, and total number of params, trainable params and non-trainable params, which is 0. Then we are making a custom callback class for logging, and then instabling for the custom callback. Next, we're gonna train the network actually. It should be network. We are training the network with training the images and training the labels, and we finished the accuracy with 0.832 and reached the value of 5.61, and then finished the epoch 5 with the value of 0.7182, and then the value is 0.65. Finally, we are plotting the results. So we wrote the function to plot the details, and we can see the plot for the accuracy curves, which shows the epoch and the accuracy, where the blue line represents the training accuracy and the red line represents the validation accuracy. Then, did the network presents the sign of overfitting in which epoch? So basically, overfitting analysis look at the training validation loss. If the validation, if the validation loss started increasing, then the training loss keeps on decreasing and overfitting has occurred. That's the basically the main major reason of having the overfitting. Then we have a question like write down how many layers in this model and identify their types. So basically we have to continue and identify the model layers and using that to list all the layers. And now how many layers are their types, we have to see that. That's the main point. Then we are adding one or more convolution layers to our model and run it again. So basically we are doing this and this code is running properly. Then we are calling back the result plotting function to display the results from our code. And then I wrote the answer for the add a dropout layer of our model and run it and compare the results with the previous one. So basically, we are re-importing the libraries, loading the dataset, converting the labels from categorical format, building the model with the dropout, adding the convolution layers, dense layers, dropout layers, output layer, compiling the model, training the model, and then plotting the results. And then we are running the plotting function. Significantly, we are evaluating the model's performance on the test data and plotting the function example to make sure that this is provided for our custom function. So we are plotting the training validation accuracies and their loss values. Then we are compiling a new model according to the question and then training the neural network with the new model, calling the results, plotting it to display the results from our code. Last question is explain with your own words what is the purpose of the dropout layer and how it works. So basically, the purpose of the dropout layer is to prevent the overfitting in the neural network by randomly dropping out, like selecting a percentage of a neurons during the training time. This ensures that model does not rely too heavily on a specific neuron and forces the network to learn more robust and generalized patterns. How it works? So basically, during a training, a fraction of neuron in the layer randomly set to 0 at a first step based on the specified dropout rate. Here is the example for the same. And this forced the model to learn the representation of the data, making it less sensitive to small changes and improve its generalization on unseen data. So basically, dropout is typically used during the training, and full network is used during the inference or testing. During the testing, no neurons are dropped, but the weights are scaled down by the dropout rate to compensate for the missing neurons during the training. So that's all for my assignment 3. Thank you.